A lot of questions on the ACT involve understanding graphs. I assume everyone knows how to plot a point on a graph. Each point is defined by an x-coordinate and a y-coordinate. Any 2 points on a graph determine a straight line. Most of the questions you will get involving graphs will be about straight lines. Let's do definitions first. An intercept is where the line crosses a given axis. The y-intercept, for example, is where the line crosses the y-axis. Intercepts are very useful, as we will see. The slope of a line is basically its tilt. If it goes up from left to right, the slope is positive, and if it goes down, it's negative. The equation of a straight line involves an x term and a y term and a number. The standard form of an equation for a straight line is, for example, 3x plus 4y equals 12. Now, the easiest way to plot this line on a graph is to find the intercepts. At the y-intercept, x is equal to 0. So if we plug x equals 0 into the equation, we can solve for the y-intercept. For this line, when x equals 0, y equals 3. Similarly, we can find the x-intercept, which is x equals 4 and y equals 0. So if we plot the points 4, 0, the x-intercept, and 0, 3, the y-intercept, on a graph, we can draw the line. Okay, so what are we expected to know about lines on a graph? First of all, the slope, which you probably know as rise over run. For this line, using the intercepts as our 2 points, the rise is 3 and the run is 4. Because the line slopes down from left to right, the slope is negative 3/4. Using the slope formula, it would be 0 minus 3 divided by 4 minus 0, which is negative 3/4. If you reverse the order of the points, you reverse both signs for numerator and denominator so that the sign of the fraction stays the same. It's a good idea to check the direction of the line and make sure the sign of the slope is correct. Now, the most useful form of the equation of a straight line is called the slope-intercept form. If we solve the equation for y, the resulting equation will tell us the slope and the y-intercept. Let's do it with this equation. Subtract 3x from both sides. So now we have 4y equals 12 minus 3x. Now divide by 4, and we have y equals 3 minus 3/4 x. In the slope-intercept form, the x term is written before the number. So we make this y equals negative 3/4 x plus 3. The coefficient of the x term is the slope, negative 3/4, and the number is the y-intercept, 3. All right, here are some important facts about straight lines. 2 lines that are parallel have the same slope. 2 lines that are perpendicular have negative reciprocal slopes. What does that mean? Negative reciprocal means flip the fraction over and change the sign. So the slope of a line perpendicular to this line, 3x plus 4y equals 12, would be 4 over 3. We turned the fraction upside down and changed the sign. One thing you might be asked is to find the midpoint of 2 points on a graph. This is the simplest thing to do. The coordinates of the midpoint are the averages of the x and y coordinates of the 2 points. Remember to observe the signs. Well, let's try a question. What is the midpoint of the points with coordinates 5, negative 3, and 13, 7? Well, the average of the x coordinates is 5 plus 13 divided by 2, or 9. The average of the y-coordinates is negative 3 plus 7 divided by 2. That's 4 divided by 2, or 2. So the midpoint has the coordinates 9, 2. Now it's time to talk about the distance between 2 points on a graph. Maybe you remember the complicated formula that involves a long square root. That formula is simply the Pythagorean theorem. So if you can't remember it, make a graph with the 2 points you want to know the distance between. Then draw a line parallel to the x-axis through one point and a line parallel to the y-axis through the other. These two lines and the line between the points make a right triangle. The distance is the hypotenuse of that triangle. Let's try it. Let's try the points 3, 2 and 6, 5. The difference in the x direction is 3. The difference in the y direction is also 3. So those are the sides, the legs of a right triangle. And you know what the hypotenuse of a right triangle that has sides both 3. Yes, of course, that's the isosceles right triangle. So the hypotenuse is 3 times the square root of 2. If you don't remember the distance formula, learn to do distance on a graph this way. All right, there are various kinds of ratio problems that appear on the ACT, so let's look at what form they take. Whenever you have two quantities and you know the value of twice of one of them and once of the other, you can solve for the remaining value with an equation that puts two ratios equal to each other. This kind of an equation is called a proportion. Here are some of the kinds of questions that you can solve this way, and then we'll do one so you'll see what we're talking about here. The shadow problem. If a 100-foot building casts a 25-foot shadow, how long a shadow does a 6-foot man cast? All right, here's how you do it. Set up the two ratios. 100 divided by 25. The height of the building divided by its shadow equals 6 divided by x. The height of the man divided by his shadow. Now you solve a proportion by cross multiplying and putting the cross multiples equal to each other. So 100x equals 6 times 25, or 150. X equals 150 over 100, or 3 over 2, or it could be also written as 1.5. Be sure to get the same quantities in the numerator and the same ones in the denominator. Here we have the height of the object in the numerator and the length of the shadow in the denominator. Other kinds of problems that are solved this way are recipe questions. For example, if it takes 2 cups of sugar to make 7 cakes, how many cups do you need to make 35 cakes? 2 over 7 equals x over 35. Cross multiply and solve. Map problems. Scale model questions. They're solved the same way. Some geometry problems also require proportions. Similar figures have the same angles and proportional sides. So for example, if we have a triangle with sides 3, 4, and 5, and another triangle with sides 6 and 8, and we don't know the third side, well, of course, you know that's a Pythagorean triplet. But if you didn't, you would do it with a proportion. One triangle has a 3, the other one has a corresponding side of 6. So we would have 3 over 6 as one fraction. Now we want to find the hypotenuse of the second triangle. So the first one has a hypotenuse of 5, and we put that over x. 3 over 6 equals 5 over x. Solve for x, and we're going to get 10. The technique of cross-multiplying can also be used any time that there are fractions, regardless of what the fractions look like. Here's question 41 from a recent test. Well, whenever you see this form, two fractions put equal to each other, cross-multiply. So 5 times 3x minus y equals 2 times x plus y. Distribute and combine terms, and you have 13x equals 7y. Now you can see that you can solve for x over y. Just divide each side by y and divide each side by 13, and you get x over y equals 7 over 13. Okay, it's time to tackle percentages. To start with, percentage means parts of 100. And a percentage like 23% can be written either as 23 over 100 or 0.23. We will use the latter representation. Many percentage problems can be simplified with the following definitions. The word is means equal. The word of means multiply. Let's see how this works. What is 25% of 64? On one side of the equal sign is what? Well, we represent that by an x because we don't know. On the other side of the equal sign, the word is, we have 25% of 64, which means 0.25 times 64. The equation is x equals 0.25 times 64, which is 16. That's all there is to percentages. All right, let's try this one. If 25% of a number is 18, what is the number? So the equation is 0.25 times x, the number that we don't know, equals 18. Divide both sides by 0.25, and you get x equals 72. And one more type of problem. What percentage of 35 is 7? So x times 35 equals 7. So x equals 7 divided by 35, or 0.20. So now remember, to change this to a percentage, you have to multiply it by 100, so it's 20%. For real problems, it's handy to know the following. The percentages of a whole have to add up to 100. For example, if a $900 computer is on sale at 30% discount, what is the sale price? Well, you can solve this by finding 30% of 900, which is set 270, and subtracting it from 900. But you can do this problem in one step by calculating that if the discount is 30%, the part remaining, which is the sale price, is 70%. So we could get the answer faster just by taking 70% of 900, which is 630. Okay, there's often a combination problem on the test. And combinations are relatively easy. All you do is write down the number for each choice and multiply them together. Well, all right, there are a couple of harder ones, but let's have some examples. Here's the ice cream problem. It involves quantities that are not affected by anything else that happens. So if an ice cream store sells 5 kinds of ice cream, 4 kinds of toppings, and 3 kinds of cones, how many combinations of one ice cream, 1 topping, and 1 cone are there? Well, there are 5 and 4 and 3 choices for the 3 things, and you just multiply them together. Okay, let's make it a little harder. This is the committee problem. You have 10 people, and you want to form a committee of 4 people with a chairman, a secretary, a treasurer, and a gopher. How many different committees are possible? Well, this is a combination problem where order matters. If we pick Joe first, and he's the chairman, then Jim, Joan, and Jerry, it's a different committee than if we pick Jerry first. Now be careful. There are 10 choices for the chairman, but the next number is 9, because we already picked 1. Then 8, then 7. So you just multiply those numbers together. Okay, now for the committee problem where order doesn't matter. We're just going to pick 4 people and let them choose the officers. So now we have a lot of duplication because it doesn't matter if we pick Jerry, Joan, Jim, or Joe first. It's going to be the same 4 people. Trust me on this. If you get a combination problem where order doesn't matter, do the same thing that you did, 10 times 9 times 8 times 7, and then divide by the factorial of the number of people on the committee. In this case, it's 4. All right, let's review what a factorial is. It's written 4 with an exclamation mark, and it's equal to 4 times 3 times 2 times 1. Just make that adjustment, and you'll get the answer right. Okay, one more wrinkle, and then we'll be through with combinations. If there's a restricted place, fill that one first. For example, if you're going to take a picture of 4 people, but the tallest person cannot be on either end, how many combinations of lineups are possible? Well, we have to start with the restricted positions. One end is restricted to 3. Can't have the tallest. And the other end is then restricted to 2. Can't have the tallest, and 1 is gone. Then we will fill another slot, and there are 2 left because we put the tallest back in the pool. And finally, the last one. So the number of combinations is 3 times 2 times 2 times 1 equals 12. Always do the restricted positions first. Some sort of probability question is also likely to come up. A probability is the number of times you get what you want divided by the number of things that can happen. Try this question. If there are 7 blue shirts, 6 gray shirts, and 4 black shirts in your drawer, what's the chance, if you pick a shirt at random, that it will not be black? Okay, there are 17 shirts altogether, so that's our denominator. 13 of the shirts are not black, so that's our numerator. The probability is 13/17. It's as simple as that. All right, just a few words about word problems. Word problems give everybody trouble. Try to step back and figure out what the question is about. Try to put the words into equations, or at least numbers that you can work with. Let's take a look at one. Danica is trying to encourage her classmates to donate books for the fundraiser and book drive for the local library. Danica will donate $35 plus 7 cents for each book donated by her classmates. Which of the following equations gives Danica's donation D dollars if B books are donated by her classmates? The choices are A, D equals 35 plus 0.07B. B, D equals 35 plus 0.7B. Choice C, D equals 35 plus 7B. Choice D, D equals 35.07B. And E, D equals 42B. Now let's step back and look at this problem. It says she'll donate $35 plus 7 cents for each book donated by her classmate. But that doesn't make any sense to interpret it that she'll donate $35.07 for each book. It must mean she will donate $35 anyway, and then another 7 cents for each book. If that's the case, D equals 35, what she will donate separately, plus 0.07, the amount for each book, times B, the number of books. So the answer is A.